So if you're learning Solana for the first time, you've probably encountered this mysterious three-dimensional object and wondered, what is it? What does it want from me, and will it hurt me? Join QuickNode as we answer the 10 most popular beginner questions, including what this thing actually is. Wait a second. So I was teaching a class recently, and I realized that the things people were asking when they first start on-chain development now are the same things I was asking a couple of years ago when I first started building Rust programs. So the first thing I want to talk about is instructions that process instructions. If you've done the right thing and you've read all the documentation, you will know that front-end TypeScript, Rust tests, and other programs send instructions to your program. But then you'll also read that your program has instructions that run those instructions. It doesn't really make sense. Is an instruction the information on the network, or is an instruction the function that processes that information? It's been famously said that there's two hard problems in computer science: cache invalidation, naming things, and off-by-one errors. And Solana generally is not very good at the naming things part. So what I like to do is rename the instruction functions instruction handler. In fact, if you look at the programs that I make, the instructions directory is actually called handlers. You can think of an instruction handler just like a request handler on a web server. Some information comes in from the network, and then you have a function that does some processing. In your anchor program, in librs, you will have a struct with the program attribute on it. That's your Solana program, and the top level functions inside are our instruction handler. Next thing I want to talk about is where you have two things with the same name. You have a instruction handler that's called something like DoThing, and that'll be spelled do_thing in lowercase. And there'll be a struct of accounts that the DoThing function uses that's also called DoThing. It's another case of bad naming. Generally in programs, when you have something that has a verb as a name, it's going to be a function. So if you want to, you can actually rename that account struct to something like DoThing accounts. That may actually make it clearer. Next thing I want to talk about is pubkeys that aren't actually pubkeys. Solana has a type called pubkey, but if you hover over it, you'll see that it actually just refers to any address on Solana. If you know anything about cryptography, you'll know that pubkeys always have matching private keys. But due to this silly naming, that's not actually true on Solana. Please just think of the pubkey type as address. In fact, you could even make an alias for it. Some of those addresses will be real public keys, but others will be program-derived addresses, which are made up from input seed. For example, the text order and our order ID number. Those PDA addresses do not have matching private keys. They're not pub keys in the traditional sense of the word, but Solana still uses the pubkey type on it for now. So number 4, let's switch it up a little. What happens if something fails inside an instruction handler? So for example, in the takeoff instruction handler, we have two functions. One of them moves the tokens in the vault to the taker, and the other sends the tokens the maker wants from the taker to the maker. What if the first one of those succeeds, but the second one fails for some reason? So Solana instruction handlers must return OK in order for the instructions changes to take effect. So if the first function in an instruction handler works, but the second function fails, that entire instruction fails, and thereby the transaction fails. No changes will be made in the blockchain. So that instruction will never be half done. It will either finish successfully or it won't run at all. Next thing I want to talk about is where are the transactions in my program? In Solana, we're always talking about instructions and instruction handlers. Where do transactions fit into this? And the answer is that a transaction will actually have one or more instructions, and those instructions are often for completely separate programs. For example, I might get a flash loan by having the first instruction go to a flash loan program. I might go and do a bunch of swaps in the second, third, and fourth instruction. I might write a note out to the blockchain using the memo program in that second last instruction, and then I will return the funds I originally borrowed in the final instruction. Now, it's one instruction talking to 3 different programs. If any of those instruction handlers in any of those programs fail, the entire transaction will fail. So yes, if any of the functions in an instruction handler fail, the instruction fails. If any of the instructions in a transaction fail, the whole transaction fails. Next question is, how can we specify an account that doesn't already exist? So you'll notice if we make an instruction for make offer, we're going to specify the vault account and the offer account, even though we haven't actually made those accounts yet. And the answer is that when you specify the accounts that you're going to use as part of a program, you're really just specifying the addresses of those accounts. Solana makes you specify the addresses you want to use as part of your transaction so it can process multiple transactions in parallel. So when you specify the vault and the offer account you're going to use in make offer, really what you're saying to Solana is that no other transaction that is going to use those addresses can run in parallel. So yes, you can specify an account even if it doesn't exist yet, because you're just saying this is an address that your transaction will use. The next question is, why are we letting the clients specify IDs to use? So in our example program, when someone runs the make offer instruction handler, they're going to say what ID they want to use. That seems unusual. Normally, in a server-side program, you would create a UUID and use that. Well, the first thing is that it's hard for on-chain programs to come up with random numbers. Part of the concept of blockchain is you have multiple nodes all across the world that are going to behave deterministically. So that concept doesn't really go well with the idea of having the blockchain think of a random address. Blockchains can't do randomness very well. Secondly, our program actually has logic in it to handle if this address already exists. So really, what we're saying in the client, again, is I just want to use the order with this ID. Our program will take care of making sure things like that order ID doesn't already exist. In our case, our program has init on the order. So if the order already exists, that instruction handler will fail. Next question is, where do I specify the argument? Sometimes when you look at a Solana instruction handler, it seems like some of the arguments are missing. And the answer pretty much is always those arguments are actually coming from the accounts that people are specifying when they run that instruction handler. For example, in our swap program, when someone runs make offer, they actually set the ID they want explicitly as an argument for the instruction handler. But in take offer and refund offer, they don't need to do that. Why? Because we already know where to find the offer. It's in the offer account. So if it seems like there's a argument missing in a Solana program's instruction handler, it's probably actually getting that information from the accounts. The next thing I want to talk about is the concept of owner versus authority. If I look at the token account in my swap program, the one I use for the vault, you'll see the owner is actually the token program. That's because users and other programs interact with the token program to make changes to this account. However, the authority on that token account is my offer PDA. So you can think of the authority as the boss of the account, whereas the owner is the program that people will interact with to change that account. Note, this is how it works in TypeScript and Rust. Some of the Solana explorers have attempted to make this easier by using the word owner to refer to the authority for an account. Finally, what's this mysterious three-dimensional object? Well, we're not going to summon the sender bytes, but we will summon the signers, seeds, and bytes. Now, Anchor calls it signer seeds, but signers, seeds, bytes is actually a better name. That was suggested by Andrew Fancong for my Turbine class, and I'm going to be using that from now on. Signers, seeds, bytes is a really good way of thinking about this because the outer array are all the signers. Seeds are the individual seeds used to create that account. So if I'm transferring tokens from an account owned by my offer, then the first signer is my offer. There's only one signer in that outer array. The seeds will be the individual seeds used to make up that offer, like the text offer and the ID number of the offer. And the bytes are the actual bytes representing those individual seeds. So OFFER in bytes, and the bytes for the 64-bit offer ID. Signers, seeds, bytes. It's not that scary. I hope that was useful, and I'll see you in the next video.